So thanks for coming out. This conference, the keynotes were actually quite interesting this morning. I really enjoyed listening to those. And hopefully you did too. I think there's very exciting things happening in this space around edge and networking with the Linux Foundation. There's so many things going on at a rapid pace. So today I just wanted to go through really quickly. This is a short lightning talk. It's not very long. I've got just a few things to mention here. So a short intro about myself before I get in. I'm Cameron Seader. I work for SUSE as a technology strategist and a director of technical sales at SUSE. And I've been with SUSE for, gosh, nearly 18 years, and quite a long time. If you think about where SUSE is now, they have only been in the business for a little over 30 years. So I've been with them for quite a while and through a lot of change. I did a lot of stuff in the OpenStack world. I went to every single summit and did about 3 different talks at every single one of them. It was quite fun while it lasted. And now here we are doing a lot more stuff in Kubernetes and Edge, and it's super exciting. And hopefully we're hitting the right direction now. So what I want to talk about here today is edge computing definitions. There really is not one definition out there. And if you've been in Edge for a little while, you'll understand that everybody talks about it differently. And that's okay, because these environments kind of have similar themes that I've kind of noticed. There's things like, and this particular diagram just shows that it's a survey that was given by the Distributed Cloud Series that gathered a bunch of data on, what is the definition of cloud or edge computing, and these were kind of the themes that came up, and the majority of what people would say. Essentially, it comes down to it's either a remote site or it's a regional cloud service that's connected to a remote site, or a remote device that is generating data or doing analytics at that remote site, or doing some level of processing at that remote site. A lot of different themes in there, but they're all common themes in this particular definition of edge computing. Now, further to that, in these surveys, we have some prioritization around these organizations. Companies today are prioritizing edge computing as a priority. Some of them said it was a top 5, some of it was a top 10. Nonetheless, it is a top priority. May not be the number 1, but it's top of the list. But edge computing is also becoming top of the IT budget as well. So if you take a look at further in this survey that was done by Distributed Cloud Series, looking at the question posed, approximately what percentage of your organization overall IT budget is dedicated to supporting edge locations. And if you look at the percentage, the 42%, that's pretty high. That's a pretty significant amount. And I think you can learn a lot from this particular survey, in that if you read between the lines, there's some other things going on there. Maybe there is, their edge locations have analytics at the edge that they're taking care of. A lot of operational things are going on at the edge that we may not really think about all the time, especially if you're looking at industries that are industrial industries, retail industries. There's a lot of moving parts there at the edge that we may not really think about, that operationally we're taking care of, that play a big role into edge computing. Looking at product lifecycle and the stage that we are possibly in, according to BCG analysis, edge is kind of at the introduction. Now, yeah, there's a lot of momentum there, as we learned this morning. And I think we're going to hear more of that in tomorrow's keynotes as analysts come and speak to us about what's going on with this growth, right? And we've seen this for a while, for the past 5 years in containers, where that growth has really picked up a lot of momentum. And we've continually seen that with IoT devices as well, both in the industrial edge, retail, and others. In these common themes throughout this many different surveys that have been done, and throughout some of the experiences we've had here at SUSE, we have seen many different challenges when talking about edge, things that we have observed through customers we've been working with, and some of these customers, although we haven't coined the definition of edge in the past 10 years, some of these customers we've been working with for 10 plus years in the edge space. It's just evolved through cloud native and the adoption of cloud native. But there's been quite a lack of consistent platform from the core to the edge to the cloud. A lot of people trying to make those connections between cloud and core that might run on-prem or inside your own data center. So they have a lack of consistency between those platforms, whether it's the operating system that's not consistent, or whether it's not consistent as far as the deployment framework or the automation that's used. There are tools that you can use today that give you that consistency. There's also been great concern, of course, around security and privacy, making sure that the code that you're using is gone through any level of checks or checking in the industry, any level of at SUSE what we like to call a secure supply chain. We make sure that our software goes through a certain level of supply chain checks from a security level and compliance, making sure there's a certain level of privacy that's involved there. Another concern or challenge could be there is the complexity of edge use cases. They do get very complex. I don't think there's any one edge deployment that is really simple to tackle, really. It always involves some level of custom consulting engagement. At least that's what we've found at SUSE, is enabling our consulting organization to come in and look at some of the challenges that you're trying to tackle and helping you along the way. It just seems like every single situation requires a complex look at the situation. Another thing that seems to come along with that when we are talking about the edge is the technology stacks that we bring with it. And it could be an application stack, it could be a database, it could be an analytics platform, anything that might be running in your own data center today that you're trying to move to the edge, but it's not built for the edge, right? So there's that realization that that the application that you're looking at running at the edge may not fit there, or might not be built for the edge. And there could be many reasons because of that. Sometimes the edge, and I hate that word small, but it's kind of true. I think small could be a couple of different things. It could be a small footprint, meaning that the operating system that you are using should probably be a smaller footprint, so that it's much more secure. It doesn't require operational attendance, like some of your data center applications take. But it needs to be also flexible. You also have to have reliability, security at the edge. Some of these things can be quite challenging if you're not choosing the right tools and the right design for your edge platform. Automation of operations designed to scale. All of these things are really some requirements of the edge. And hopefully you've seen a lot of these things, as you've been tackling your own edge solutions. These are just some things that we've seen as common requirements. Just looking holistically at an environment. So this is kind of an example, basically, of an environment that you could have out there. This is a possibility in retail or industrial or manufacturing, where you have 3,000 plus locations, with the possibility of having Kubernetes at the edge, which could be as small as 3 nodes, or as big as, I don't know. It doesn't really have an end, right? It could be a dozen nodes, it could be 24 nodes, or 5 nodes for a Kubernetes cluster. But it could be driving multiple applications. But your Kubernetes nodes could get up to around 9,000, possibly. That's a lot of systems to manage for Kubernetes. Along with that, you may have IoT devices that are connected. And those could be up to 60,000, across 3,000 locations. This is just a reference, but this is a possibility. This is a scale problem at the edge. So how do you manage that, is the question. How do you onboard something like this? How do you onboard a new location or new locations? And how do you do that effectively and efficiently? How do you patch the operating system or any of the applications running there? These are all major challenges at the edge, especially when you start looking at scale. So that's a lot of runway to get up to this point. But SUSE's edge solution helps to tackle a lot of this. So our unique approach. We are purpose-built for the edge. Our platform is lightweight, from the operating system all the way on up to the Kubernetes distribution. And we have a couple of different choices from a distribution perspective. It is fully containerized, so that gives you a lot of flexibility. When you containerize everything, your applications are easily deployed, and also easily deployed exactly the same in multiple environments, multiple locations, so you can replicate that much easier. So it's really designed to scale, to handle 3,000 plus locations. And we've done this. It's also secure and reliable from the secure supply chain all the way on to the edge location itself. If you decide that you want to make everything disconnected and operate that way, you can, and keep it much more secure. We also are able to automate things operationally using our tool set, which reduces a lot of complexity in the environment. We also support existing infrastructure. So if you are doing something on-prem or need to plug directly into infrastructure that you already have, and maybe it's stuff that runs already in the public cloud, doesn't matter what public cloud provider it is, we support all the major cloud providers today. So we simplify operations by reducing the complexity. And what that means is we are able to onboard new environments rather quickly, actually, by removing the need for on-site technical expertise. So really you can handle the onboarding and the scale of this environment all remotely. It doesn't require expertise to have to put boots on the ground and go out to the location. You can manage this all remotely, which is rather impressive. And it's a cluster management stack that is really point and click, but also has the features and functionality built into it, for a DevOps or platform engineering group to be able to handle and scale this environment. And for the OS management, of course, it's much easier to manage when it's all built into the platform and managed by a single platform. So the SUSE Edge, and now we're at 2.0, it's a set of 3 core products today. Those 3 core products are the SUSE Rancher product, which is your management stack that gives you the ability to manage Kubernetes at scale, no matter if it's on-prem or in the cloud. We have drivers and connectors for any cloud environment. And we also have a set of Kubernetes distributions, one called K3S, which is a lightweight single binary Kubernetes distribution. And then we also have RKE2, which is kind of a derivative of that. It's a containerd based Kubernetes distribution. They actually both use containerd, but K3S is single binary installation. We also have SLE Micro, which is the underlying operating system that we utilize for this. And it is a micro version of SUSE Linux Enterprise that is immutable. So the patches and updates actually come down through the SUSE Rancher environment and are all enabled through a containerized ecosystem today, which is rather impressive. So you can actually put your operating system images into a container registry and update the operating system through that methodology. It's all cloud native based, which is quite interesting, very unique. On top of that, you have a choice to add in extra functionality such as our new vector container security platform, which gives you the zero trust security that you require at the edge. And you can manage all that all remotely as well. And then, of course, we have our Longhorn storage that ties into that from a cloud-native perspective as well. Any questions up to this point?
So this Longhorn storage is like provisioned on SSD?
It can be, yes. SSD or spinning disk, depending on whatever you could use, any type of hardware. Obviously, like SSD is going to be better.
Storage, right? You leverage the same compute resources, right?
Yep. Yep. Happy to talk about that further. I think we're kind of at a stopping point. But I'm happy to catch you outside. Yeah, we'll do one more question. Yeah.
I mean, listening to you, it seems like you should avoid doing edges as far as you can and try to be centralized in your computer.
Not necessarily.
Simplify everything. You started the output saying how complex it is.
Yeah. Yeah.
So is there a sort of other people doing edge for the wrong reasons?
Well, we operate in according to our platform, we operate in kind of a hub-spoke model, which means that you could actually have your management from a centralized location, but you don't have to. So you could have one in the centralized location and then another that actually manages from the cloud down to your edge location. So it's just really all about how you set it up. There's multiple architectures that we can go through with you on the way that this is set up. But sorry.
I'm afraid of the multiple architectures.
We can keep it as simple and or as complex as you like. It's different things require different architectures. So depending on your situation, but we like to try to keep it as simple as possible. Okay, yep, we got to stop. So thank you.